Hello everyone and welcome back. My name is Mr. Covalt, and in this video I'm going to be going over how to predict precipitation reactions. What are the products that are going to form, if any? So when you're trying to predict the products of your precipitation reaction to see if you get a reaction or not, you first have to identify what the possible products are. The reason I say possible products is because you don't know if these products are actually going to form when you mix the two solutions together. Will the ions come together to form a precipitate is the question. If they come together to form a precipitate, then you have a reaction. If nothing comes together to form any sort of precipitate, then there's no reaction. Unless, of course, it's a gas evolution reaction, but that's for another video. Here, we're just looking at the combination of two ionic substances that are aqueous and seeing if you get a solid that forms. And if you don't get a solid that forms, then there's no reaction. Okay, so let's get into this. So the first set of problems we have our silver nitrate and sodium phosphate. We're going to mix those together and we're going to see, okay, is there a precipitate that forms? The first thing you need to do is write out what the possible products are. So we'll continue with our arrow here. So what are the possible products? What do you do to figure out the possible products? Well, you swap the ions. So the two inside ions go together. So the nitrate and the sodium will go together. And then you put the silver and the phosphate together as a product. So the important thing here is when you create your products, all you're doing is you're putting the ions together, but you also need to balance the charge to get the right formula. So if I take the outside ions, silver is a +1 charge, the phosphate is a -3 charge, so I'm going to need 3 silvers to balance the charge. Or you could also do the crisscross with the crisscross method with the charges as subscripts. So here I'm going to have, so I have Ag plus, and I have PO4 3 minus. I can do the crisscross method where this 3 becomes a 3 subscript for the aqueous. This 1 becomes a 1 down here. So then the formula becomes Ag3 PO4, like so. That's one possible product. Then I'm going to add to that the other possible product. So I'm going to put the sodium and the nitrate together. Sodium is a +1 charge. Nitrate is a -1. So the 1, 1 each will balance the charge. So then I get NaNO3. Let me move this over. So now that I have my two products, the next thing you need to do is to determine if what the state of matter these are going to be. Is this going to be aqueous? Are these going to be aqueous, or are one of them going to be a solid? Is it going to precipitate? Well, that's where the solubility rules come in. So you need a solubility table or solubility rules that you can look up to see if anything is going to precipitate out. Or in other words, I'm looking to see if either one of these is insoluble in water. If it's insoluble in water, meaning it's not going to dissolve in water, then this will form a solid. If they are soluble in water, then they're going to dissociate and become ions in water. They're not going to come together. They're going to be aqueous. Okay, so silver phosphate. Let's look at the rule for phosphates. It says phosphates are generally insoluble except for group 1 and ammonium. If you have a group 1 metal or ammonium with your phosphate, then it's going to be soluble. Otherwise, it's going to be insoluble. So this is silver. So silver is not in those categories. So this is going to be solid. The rule here, we have sodium and nitrates. The rule for nitrates is that all nitrates are soluble. They're going to be aqueous. So there's no nitrates are going to form a solid. So this is going to be aqueous. And so these are the products that you would predict. I'm not balancing the equations, but you normally would balance the equations by putting coefficients to balance the equations. If you don't know how to balance an equation, then go back to my videos where I talk about how to balance equations, and I go through a lot of examples of those. So check those videos out. Okay, so this is going to react. So these are going to react to form your silver phosphate. Okay, next we have barium chloride being mixed with sodium sulfate. So let's see what that's going to do. Again, the inside ions go together and then the outside ions. So we're going to see what possible products we would get. So here, so I'm going to take the outside ions, so the barium, right? So the barium and the sulfate will go together. So barium has a 2+ charge. Sulfate has a -2 charge. So they balance the charge one each. So I just need one each to balance the charge. So that's going to be BaSO4. So that's one possible product. And then I have sodium and chloride ion. So these two will go together. So that's going to be, again, the sodium has a +1 charge. The chloride ion has a -1 charge. So one each will balance out. So 1 to 1. So I'm going to write NaCl. So these are the balanced formulas for my possible products. So now I need to see if I'm going to get a precipitate with any of these combinations. Will I get a solid? Are any of these or either one of these going to be insoluble in water? That's going to be a solid. So we got to go to our solubility rules to see what is soluble and what is not soluble. So let's look at sulfates. So the rule for sulfates says that compounds containing sulfate are water soluble except with barium or lead-2. So sulfates are going to be soluble unless they're with barium or lead-2 ion. So we have a sulfate and it is with barium, so that is going to be insoluble. So that's going to be a solid. That's our precipitate. And if we look up chlorides, in the rules, the solubility rules or a table, it says that compounds containing chloride, bromide, iodide ions are going to be water soluble except when they're with silver or lead-2 ions. So here we don't have silver or lead-2, so this is going to be soluble. So it's aqueous. So in this case, we do form a product. So we do have a barium sulfate precipitate. So there is a reaction going on here. So both of these will form a reaction. They'll form a product. So let's go on to the third one. Here we have lead-2 nitrate mixed with sodium acetate. So again, first thing we're going to do is form our possible products. So we'll put the inside ions together, so the nitrate and the sodium. And we'll put the lead-2 ion together with the acetate ion. So let's see what happens here. So lead-2 to acetate. So the lead-2 ion has a +2 charge. The acetate ion has a -1 charge. So we need to balance the charge. So to balance the +2 on the lead-2 ion, we need 2 of these. So when we form our product, we're going to have Pb and then C2H3O2 with a 2 on the outside. So that's one possible product. And now we're going to do the inside ion, sodium with nitrate, and we're going to get NaNO3. Again, sodium here has a +1 charge. Nitrate has a -1 charge. So you only need one each to balance the charge. So I have one sodium, one nitrate. So that's my formula for the other product. So now we have to use our solubility rules to find out if any of these are going to be a precipitate. Is it going to form a solid? Are any of these insoluble in water, or are they both soluble in water? So if you look at your solubility rules in your table, you'll find that all acetates compounds are soluble in water. They're all aqueous, so there's no exceptions to this. So this is going to be aqueous. Also, if you look at your solubility rules, you'll find that all nitrates are soluble. There's no exceptions. So no matter what, if you have a nitrate in your compound, it's going to be soluble. So it's going to be aqueous. And there you go. Next, we have calcium chloride and we have sodium phosphate. So again, we're going to figure out what our possible products are. So we're going to put the outside ions together, so the calcium and the phosphate, and we're going to put our inside ions together, the sodium and the chloride ion. So we'll put the calcium and phosphate together. So again, calcium has a +2 charge, phosphate has a -3, so we're going to have to balance the charge. Again, you can use the crisscross method. So again, let me show that. So you have Ca2 plus, and then you're going to match that with the PO4 3 minus. And now all I'm going to do is crisscross the charge numbers. So the 3 goes down here as a subscript. So 3 down there. And then the 2 goes here. So I'm going to end up with Ca3 parentheses PO4 2. So that's my formula that has balanced charge. So then I'll rewrite that here. So I'm going to have Ca3 PO4 2. So that's my first possible product. Next is I have sodium. I'm going to put sodium and chloride ion together. So we've seen that. So sodium is a +1, chloride is a -1. So that's going to be balanced. So 1 to 1 each. So again, that's going to be NaCl. So again, we're going to look up our phosphate. The rule for phosphate, again, is that compounds containing phosphates are insoluble. Insoluble except for group 1 metallics or metals and ammonium. So here we have a group 2 metal, so that doesn't apply. So that's going to be insoluble. So there's our precipitate. We got a solid. And then if we look at sodium chloride, again, chlorides are going to be soluble in water unless you have silver or lead-2 ions. And so we don't have any of those. So this is going to be aqueous. Okay, next. So here we have a reaction. Now, one of the things I want to point out here, I forgot to point out in number 3, is that we got aqueous and aqueous. And now we have aqueous and aqueous. So here we don't have any products forming because there's no precipitate, there's no gas, there's no liquid. It's just aqueous, meaning that on this side you have ions floating around doing nothing. And then on this side, these ions are not together. They're floating around in solution. And these ions are not together. They're floating around in solution. So there's these ions are not coming together to form any real product. So this would be no reaction. No reaction for that. Okay, what about number 5? We have we're going to put the outside ions together. So here we're going to put the potassium with the sodium, the nitrate, sorry. And then we're going to put the inside ions together, the hydroxide with the iron 3 ion. So we'll do the potassium and the nitrate first. So potassium has a +1 charge, nitrate has a -1 charge, so we just need one each to balance the charge. So the formula would be KOH. And then we're going to add that our next compound. So we're going to put the inside ions together. So the iron 3 and the hydroxide. So the hydroxide ion has a -1 charge and the iron has a +3. So we're going to need 3 hydroxides to balance the charge of the 1 iron. So when we balance that out, again, you could do the crisscross method too to get this. Well, when you balance that out, you should get that formula there. So now that I have my formulas, my compounds, I can see which one, if any, is going to actually form. So will I get a precipitate? Are either one of these going to be insoluble in water? So let's check it out. So what about hydroxide? If you go to our solubility rules, it says that hydroxides are generally insoluble, except when you're with a group 1 element or ammonium ions, group 1 element. So generally hydroxides would be insoluble, but here we have a group 1 element, so this is going to be soluble. So this is going to be aqueous. And again, here we have hydroxide. Oops, did I make a mistake? Oops, I did make a mistake. This is supposed to be NO3. That's supposed to be nitrate. I wrote hydroxide instead. Why didn't you guys tell me? Okay, so the nitrate, again, for nitrates, there's no exceptions. All nitrates are aqueous, so it's the same thing. It's the same situation. So we have aqueous there. Now, as I said, hydroxides are generally going to be insoluble. Let me read that again. Going to be, yes, insoluble except for group 1. So we don't have a group 1 metal. We don't have ammonium here. So this is going to be insoluble. So that's going to be a solid. That's our precipitate. So we do have a reaction here. So we had a reaction here because we produced this precipitate. We have a reaction here because we produced a precipitate. Okay, next. So for these two, we're going to figure out our products again. So we're going to put the outside ions together, sodium and sulfate. And then we're going to put the acetate ion together with the calcium. So the inside goes together, the outside go together. So let's do the sodium and the sulfate. So sodium has a +1 charge. Sulfate has a -2 charge. So we're going to need 2 positives to balance the 2 negatives. So therefore, our formula is going to be Na2SO4. And here we have calcium, which is a 2+ charge, and we have the acetate ion, which is -1. So we're going to need 2 negatives here to balance the potassium. So we're going to need 2 acetate ions to balance, I'm sorry, I said potassium, to balance the calcium. So here we go. Ca and then parentheses C2H3O2. Okay, so now that we have our 2 products, what we're going to do now is see if they're soluble or insoluble. So again, sulfates, the rule is, so the rule is for sulfates, again, sulfates are water soluble except barium and lead-2. So water soluble, we don't have barium, we don't have lead-2. So this is soluble. So we have aqueous. And then for the acetate ion, if we remember from before, the acetate ion is always soluble. So any compound with an acetate ion is going to be soluble. So this is aqueous. So aqueous. So they're both aqueous again, which means that we got aqueous here. Oops. Sorry about that. So we have aqueous here. Oops, sorry, aqueous here. So these are ions floating around in solution. And then we have aqueous here for both of these ionic compounds. So the ions are floating around in solution. They're not coming together. So there's no reaction going on here. So no reaction, nothing happening. Finally, we have number 7. So number 7, again, potassium. We have potassium sulfate with lead to nitrate. So again, we're going to put the outside ions together, potassium and nitrate, and we're going to put the inside ions together, lead 2 ion sulfate, and then we'll see what products form. So let's go with the first one, which is potassium and nitrate. So the potassium ion has a +1 charge. The nitrate ion also has a -1 charge. So they're going to balance out equally. So 1 to 1. So that's going to be KOH. And so that's our first product. And now we can do the second product, put these 2 ions together, lead 2 and sulfate. So lead has a +2 charge on it because it's called lead 2. You can see that from the 2 nitrates. Nitrate is a -1. So you can know it has a lead 2, you can know it has a +2 because you need 2 nitrates to balance the charge. So then you have lead 2. Lead has a 2+ charge on it. Sulfate has a -2 on it. So they balance each other out 1 to 1. So you only need 1 each. So that's going to be PbSO4. And once again, we can see whether or not these are going to be soluble or insoluble. So we have KOH. So remember, hydroxides are going to be generally insoluble unless you have a group 1 metal. We have a group 1 metal, so therefore it's soluble. So this is going to be aqueous. And then here we saw that sulfates, let me double check, sulfates are going to be water soluble except barium and lead 2. So here we have a sulfate. This is generally going to be soluble unless you have lead 2 or barium, and here we have lead 2. So this is going to be insoluble. It's going to be a solid. So we have a precipitate here. And so therefore we have a reaction going on here, but here we don't have any reaction because no precipitate was formed. They're both aqueous ionic compounds. Okay? And so that's it, ladies and gentlemen. That's how you can predict your precipitation reactions. So again, first you want to figure out what the formulas are for your compounds, right? So you put the inside ions together, you put your outside ions together, balance the charge, get the proper formula, and then once you've got your possible products, you then look on your precipitation table to see what the rule is for that particular substance or particular ion in the substance and see if it's going to be soluble or insoluble. And then if both of the compounds or both of the products are actually soluble, it's no reaction. If you have one substance that's insoluble, then you do have a precipitate and therefore you have a reaction. That's it for this video. I hope you enjoyed this video. If you learned from this video, if this was helpful in any way, then please like the video, share the video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a problem or a concept you want me to go over, please let me know. If there's a video that you want me to do, then please let me know, and I would be happy to do that for you. Thanks for joining me, and have a great day.